Welcome to the WebMachinist CNC Machinist application. It's a great tool for machinists, CNC machinists, and manual machinists to use in helping saving you time and money in doing a lot of these calculations manually. I just want to do a quick overview of the program itself, and if you need more detail on each calculator that's within this program, and there is a lot of them. You can check our tutorials on our website at WebMachinist5, and they're on there. Anyway, I'm going to start right up here in the corner with the manual machine calculators, and you just click the button, and these are our manual machine calculators. You got a lathe cross-side calculator, you got a tailstock offset calculator, and a hex point calculator. So you just go in, click one of those, and this one lathe cross-side calculator will calculate the actual in-feed when you're at an angle on your cross-side, depending on the angle, either this angle or this angle, and what you're actually dialing in. For instance, in this one, angle A is 15 degrees, obviously angle B 75. Let's say you're moving in 12 thousandths on your dial, but you'll actually be cutting in 6.016 on radius or 0.031 on diameter. It's pretty cool, especially when you're threading that way. Also, a tailstock offset calculator. This one is, you need to know how much to offset your tailstock to make a taper angle, and you can do that by taper per foot or angle offset, either way, and it will calculate very easily out how much you need to offset off the center from this center. And finally, in the manual machine calculators, we have a mil hex pocket calculator. This is just a tool to use if you need to know the points inside of a hex to bring your end mill to, and then to go around to make this particular hex. Very easy to use. Works really well. You just input your end mill or tool size and the hex size. Also useful for drilling corners of hexes inside, based on the size of your drill. And you can also calculate the hex corner points. Like say you got a 9-inch hex here, and it'll tell you the points on there. So very, very useful. That's our manual machine calculators. Go back to the main menu. Bolt circle calculators. Very cool program. You can calculate full bolt circles, partial bolt patterns, polar points, chord to diameter calculator, and even a wheel bolt pattern calculator. Just give you an example here of one. This is a full circle calculator. Put in the number of the holes, the bolt circle diameter, angle to the first hole, easy stuff. Where your center point is. Are you doing a full circle and you want inches or millimeters, and just hit calculate, and then there you go. Gives you all the numbers. The other calculators work pretty much the same way. Wheel bolt calculator is a little different. This one, let's say you're trying to figure out the bolt pattern on a car. You just choose number of holes, in this case 5, the stud or the hole diameter, and the measurement across the stud or holes here, inches or millimeters again, and calculate, and then it tells you what the bolt pattern is. In this case 5.5292 inches. Okay, go back to the main menu. Center drills and countersinks. Got a countersink calculator in there. Can be pretty useful if you want to really quickly just figure out, say you got a countersink angle of, let's say, 55 degrees, and you need to make a diameter of, say, 1/2 inch, or it can be millimeters. Calculate, and there you go. Tells you the depth it has to be, and to do that. Back to the main menu again. Here's a really cool deal here, soft jaws calculator. Right now, I've just got the mill soft jaws, which is mostly what you need. This really works well when you're setting up a mill and you're just milling your soft jaws for certain shapes. For instance, you could just have a left stop like shown here, a full rectangle or a square, a right stop or no stop, you just want through jaws, or you want a circle. For instance, I like to put mill jaws where I'm putting in, I just have to slide the part in, have it come up against the stop, and have it figured out the program for it without having to go into a CAD CAM system. So all you got to do is click that, tell it the jaw length, or up in here, jaw length, let's say it's a 6.0 inch long jaw. Let's say you need a, let's just say a 4-inch width of a pocket. You're going to put a 125 spacer maybe in there. You need a pocket depth of, let's say you got to go down a 1/2 inch. Depth of cut at a time, say you only want to go 150 at a time. Your end mill diameter, let's say you use the 1/2 inch end mill. Just put that in there. Tool number could be anything, whatever you want to use. Your tool entry rate, let's say you want to kind of ease it in, you might want to only go 12 inches a minute or whatever it happens to be, and then when you're actually milling the pocket, let's say you want to go 25 inches a minute. And let's say you're going to do it at 6,000 RPM. So you just enter all that data and just hit OK. And then it outputs over on this side the program to do all these things. It'll mill that pocket to your specifications, and you can see everything that you put in over here. Color codes the program, makes it easier to see. Down here you can even see each time it moves down again until you get to your final depth. So works really well. Then you can either print it out, or you can copy it to your clipboard on your computer and then just paste it into your program. Very easy to use, very nice feature. There's your finish passes right there. You can add a header, footer in there if you want, which tells you, what it is, soft jaws left, spacer between X origins, left end, Y origin, center, and so on and so on. And you can also number the lines too, if you want. It's pretty neat. Okay, that's the soft jaws, and like I say, there's other types you can do too, but I get a lot of good comments on that people really like that. Going back to the main menu, have a few inspection calculators in here. There's a whole location calculator, a sign bar setup calculator, a dovetail measuring calculator, a gauge blocks calculator, a true position calculator, and a 3-wire measuring threads calculator. Whole location is pretty self-explanatory. You just put in the actual dimension, that actual measurement that you're getting from, say, a side to the center of a hole, the hole diameter, and then the edge to the hole measurement. Works very well, and there's different styles of that. Like I said, I'm not going to get real specific because I don't want to make this video too long. Another real popular one is a sign bar setup. And what's neat about this one is it'll calculate the gauge blocks for you. Let's say your desired angle is, let's say, 36.25 degrees. Your length of your sign bar, let's say, is 5 inches, pretty common. And then it tells you this is the gauge block height you need for that sign bar. to be at that angle 36.25. And then it also can print out the gauge block list for you right there. Okay. There's another pretty neat thing, drill index. Okay, your run-of-the-mill drill index, right? You got all your drills, letter drills, number drills, metric drills, fractional. You got it. Cool thing about this is if you click on, say, one of the drills, you get this screen. This screen is the drill I just picked, which out randomly, a 3/16 drill. It also gives you speeds and recommended speeds and feeds for that particular drill, different metals, all the way from alloy steels, aluminums, copper. I mean, it's just loaded. Carbon steels, stainless steels, tool steels. Very, very interesting. And that's, like I say, just by choosing a drill out of there, it'll give you all that. Go back to the main menu. There's also a lease or loan payment calculator in here. You can pick out your interest rate, your number of payments. You can create an amortization schedule, calculate your lease, save that to a file or print it, whatever you want to do. But it'll give you your payment amounts and et cetera, et cetera. Sometimes that comes in really handy. Material here, got your metal weights. All you have to do is choose out of this group. Let's just say aluminum. Choose your alloy. Let's say 6061. Let's say rectangle. Let's say the width is 2 inches by 1 inch, and the whole bar 1,244 inches, or you can do it by feet. And price per pound is optional. You don't have to put that in there. And then it'll calculate the weight, tell you the shape, just to remind you. Weight in pounds, 28.22 pounds. Cost of material at the price you put in will be $91.72. This is really useful when you're setting up a quotation and you're kind of just trying to get in the ballpark there. Really works well for that. What else? Feeds and speeds conversion calculator. Pretty cool deal. You can convert surface feet per minute to RPM, RPM to surface feet per minute, inches per minute to inches per revolution, inches per revolution to inches per minute, just by clicking one of these, inches per minute to inches per tooth, inches per tooth to inches per minute, inches per tooth to inches per revolution, inches per revolution to inches per tooth. Also on the metric side, you've got surface meters per minute to revolutions per minute. You've got revolutions per minute to surface meters per minute. Minutes per minute to millimeters per revolution in the feed conversions. Millimeters per revolution to millimeters per minute. Millimeters per minute to millimeters per tooth. Millimeters per tooth to millimeters per minute, millimeters per tooth to millimeters per revolution, and millimeters per revolution to millimeters per tooth. Interesting. Let's just take one here. Let's say your millimeters per minute is 25. Say your RPM is 3,000. Number of teeth on your cutter. Let's say you got 4 flute, and then there you go. Calculates all that stuff out for you. So that's a pretty neat deal right there. This one over here, simple lathe cam. A lot of people, a lot of shops, a lot of machinists don't really have a CAD cam for their lathe, and that's why I call this simple lathe cam. You can come in here and you can have these calculators calculate out your compensation for various angles, what have you, both OD and ID. Here's the OD. Let's say you're coming straight across right here, and you need to have the compensation for this angle going up right here. You just click that. Now you have a choice: calculate with the G-code programming or only give the calculation numbers. With the code programming is the way to go, but if you only need the numbers, go that way by all means. So you click that, and then here it's going to ask you some questions. What's the angle that you're trying to do? Let's say you're trying to do a 35-degree angle. The tooltip of your radius, very common one, is 0.0156. It's 1/64th, but you can put in whatever you want. The drawing X position is the position that you're starting at. Let's say for some reason we start at 1/250. Our Z position, where we want to start that angle, let's say is minus 0.375. And you also have the option to put in a fillet radius. If you wanted to radius this in here, you can put that in. That's optional. You don't have to have it in there. Let's go ahead and put in a 0.045 radius. Down here, depending on your programming language, you can use R for the radius or use the I and K version. Either way will work. Hit calculate, and it gives you the code. G1 X of 1/250, and it's going to G1 back to Z of minus 3764, and then it's going to G2 X of 12606, Z of minus 3933, and it's going to throw in that I value for you, 0.0294. And again, you can copy that to the clipboard or print it and then paste it into your program. You also have the option of going the other direction. See right here, the feed direction is going that way. Let's say you're coming down this way and you want to get to that point. Just click that right there. And it'll give you a little different program you can paste in there. Works really well. People really like it. It's a good program. There's also in this one a cutoff compensator. Pretty neat. For instance, you're going to cut off a part and you want to chamfer it, the back side of it, right there. Again, you just put in some values, the width of it, all that kind of good stuff, and this will make a program for you. You can even radius this corners right here. So that's a fairly new feature in WebMachinist. I don't want to be too long-winded here, but let me just kind of speed it up here a little bit. You got a screw section, socket head screws, all different kinds, standards. Click on one, they'll give you the sizes of them, that sort of thing. That's pretty straightforward. You can change the types, that sort of thing. Pretty helpful, and you can print them out, the dimensions, stuff like that. Here, drill peck calculator. This is an awesome thing if you do deep hole drilling especially. You can do either middle drill pecking or lathe. They both work pretty much the same. What's nice about this program is if you don't have any kind of drill peck cycle, which most machines do, you could probably do without this one. Same peck, full depth. Just peck in, peck, wrap it out, peck in. Next one over, reduce peck at partial depth. That's very cool. That means it'll peck the same amount until you tell it, at this depth, I want you to start reducing the peck because I'm getting deep in there. And it will. All you have to do is put in your drill depth. Your Z clearance plane is how far to wrap it out to pull the chips out. Your feed start position, which in this case we have 25 thousandths, is where you actually want it to start feeding. But this might be a clearance point, or this also be where you want it to wrap it out to. You can put in your initial peck amount. Let's just say like 250 as our initial amount. Now it'll do that 250 until it reaches that depth where you want to start reducing it. Up here is your minimum peck amount. And all that means is that when it reaches that depth and starts reducing the peck, what's the minimum peck you want it to do? Because it will reduce down to nothing if you let it. Next is reduce each peck by what? You can say 15 thousandths to reduce it. Sounds all right. Reduce peck Z start depth. In this case, when it gets down to, say, minus, let's go a little more than that, so we're going 5 inches deep. Let's go minus 2.0. So at minus 2.0, it's going to start reducing the peck amount by 15 thousandths a peck. And that's going to be coming from this peck here. This little checkbox here, just so it shows the peck amounts in the program, which is useful to see when it's actually doing it. Here, return amount after last peck, we got it set for 0.015. That just means after each peck, it's going to wrap it back down and then stop 0.015 inches or millimeters, whatever you got it set for, less than the last peck. So that's pretty self-explanatory. This box here, you can dwell, control dwell. You can put no dwell, so it'll never dwell, it'll just keep on going. You can dwell after all pecks are done, and it'll just come up, dwell, maybe you want to run coolant down in there, something like that. Or you can have it dwell after some pecks. That's when it rapids out, and or you can have it dwell, let's say, every one peck. Well, basically that would be after all pecks, but you could have it dwell, like say I only want it to dwell every 10 pecks, and I want it to come up and dwell for whatever I decide. And that's what this is right here, dwell diameter. Depending on your controller, it could be, like for instance, this would be on half a second dwell on some machines. You might have to put in 0.5 for half a second or 1.0 for a second. It just depends on your machine. And then finally on the drill peck, your feed rate. Right now this is in inches per revolution. Over on the mill side, the same program, you'd probably would be doing it in inches per minute. So anyway, that's an overview of that and how that works. Very, very neat thing to have. And let me just run through a couple more things here. Machining formulas down here. We got all kinds of formulas. Cutting feed formulas, degrees formulas, drill point depth formulas, feed rate formulas, metal removal formulas, tapping formulas, true position formula. All these they're telling you the formula to derive these answers. So there's the formula for that. Cutting speed formulas, for instance, gives you what they are, then the formulas, etc. Now the cool thing about this too is not only you get the formulas, if you look up here, you got a calculator. You can just go ahead and calculate it right there too. Pretty neat. Surface feed per minute gives you the, click that, ask it, tell you what you want. And let's say our RPM 6000. And there you go. or you can just look at the formula and figure it out yourself. But like I say, you got these handy calculators for each one of these things too. For instance, drill depth. You know, this is the different ones here, the formulas for these different degrees. You use the calculator. You can also use those basic ones, but also use a custom angle. Let's say you want something that's not in there. Let's say 54 degrees. And your diameter, let's say, is 1 inch of your tool. And then it'll give you your drill diameter, drill tip angle, and your drill tip length. So, pretty straightforward. Metal removal. You got time cutting in minutes, time cutting in seconds, distance over time in minutes, metal removal rate. Sometimes these are very handy right here when you are doing quotations. You can use the, again, you can use the calculator. And tapping formulas, all kinds of them. Calculating sizes for metric taps, calculating drills, etc., etc. There's quite a few in here. I mean, you could spend a lot of time just really going through here and finding stuff that you really like, or you can use the custom tap calculator, cutting tap for an inch, form tap, cutting tap metric, form tap. These are custom. I mean, you put in the data, like the basic, like major diameter, say 325. Let's say your thread pitch is 24, and say you want to put a 65% thread, and it'll give you all that information, and even suggest speeds and feeds for it. So, moving on, back to the main menu. The threading is a very, very good deal here. Threading covers unified threads, Acme threads, metric threads, and trapezoidal threads. So your unified threads are here. You just go ahead and click on one, and then there's all your information. Your major diameter, your minor diameter, nominal, major, in both inch and metric, pitch diameters, minor diameters, feed rate in inches and in metric, your 3-wire measurements, wire size, what your max measure over the wire should be, what your minimum measure over the wire should be, and nominal should be, etc. And it's also for ID threads. Metric threads, same thing. In this case, it gives you all the pertinent information that you need in both millimeters and inches. Same with the ID threads. It's all there. This is a really huge database for metric threads. Go to your Acme threads. You got general purpose and stub Acme threads. Just look at the general purpose, they're both basically the same. You can go down here, find your thread, and on this one you've got a chart. It'll give you a chart that you can print to get all this information. The usual stuff, the flat, the minor diameter, your pitch diameter, your major diameter, your thread pitch, etc. Your measurement over the wires, and your wire size. That's general purpose. Stub is the same thing. Another cool thing about this is there's also a custom thread for Acme. Sometimes there's not an Acme in the chart that you need. You can customize one. Go into the general purpose custom Acme calculator. For instance, here put in any thread size, 2.963, say you want 11.5 pitch. And do you want a 4G, 3G? Let's put a 3G just for the heck of it. And there it goes. Spits out all the information for your custom Acme thread. Pretty nice. Go back to the threading main menu, and now you got your metric trapezoidal threads. These are pretty much just like the other thread charts. These are all standard. In here, the usual. Got your angle in there, your thread pitch, major diameter, pitch diameter, minor diameter, flat. And those numbers are all in millimeters. Also tells you your measurement over your wires in millimeters and your best wire size. So, pretty good stuff. Of course, you got a tapping calculator. Just find your tap, and there's all your information, including speeds, suggested speeds, feeds, everything. Tap iron tell number of percent. And you have it for cutting taps, form taps, or helicoil cutting taps. You can also calculate the tap yourself. Say you need a 275 diameter tap at a 330 threads per inch, and let's say you want 65% thread, and that'll be a calculated tap. Give you all the information you need there. And you have the same thing over here for the metric tap. So you can also do custom cutting and form taps on the metric side too. Same thing. And just one last thing that's I'll just quickly show you. It's kind of interesting. Do a lot of right triangle and stuff. Well, you got trig and geometry calculators. Got your right triangles. All these different types. Just makes it a little easier to set them up, because I hate having to rotate them and what have you. Try to figure out what I'm looking at, but all you have to do is type in an angle or two sides, whatever it may be, and now it'll say enter a side only. Let's just say that's 350, and gives you the information, and you're also able to print that out too. Going back to the trig and geos calculators, here's another one, circle segment. You can calculate the segment of a circle when you know the angle and the radius. You can calculate the chord length and height. You can calculate the radius when the height is known. Radius and height is known. Pretty easy. Let's say the circle radius is 0.5, and let's say the height is 0.1. And it'll spit all that out. And it gives you extra information too, the arc length, circumference, the circle area, circle diameter, and so on and so on. So that's kind of a neat deal. And what else is in there? Area calculators. You can calculate the area per circle, a square, a rectangle, or a hexagon. I'll try to go through this a little quicker. Get it done. Hex points calculators, very similar to the one we looked at already in the manual machines. Actually, it is the same one, so we've already seen that. And finally, the 3 points calculator. If you've got 3 points on a circle that you know, but you need to know the circle center and the radius, this is pretty cool. Just put in your first point. Let's say it's at x of 1.5, y of 2.3. Let's say second point is x of 0.750. Let's say it's on y of 0.250. And the third point is, it says x of minus 4.0, so that would be interesting. And it's on y of minus 3.0. Let's see what it comes up with here. Okay. Based on this information, where these 3 points are, this is the circle center, and this is the radius of the circle. So, pretty simple. And with that, I'd like to say thank you for watching this video. I hope it helps you out with what this program does. I know it's a little long-winded, but if you need more specific, please check out WebMachinist5, and I'll have some tutorials on there as well. Thank you very much, and have a great day.